We've seen that our guessing game application really does work and lets us keep playing. We keep guessing until we guess the right number, and then it asks if we'd like to play again. When we finish playing again and type no, we get thank you for playing, goodbye. So this app works pretty well. Let's do a little bit of review inside our app and see what we've put together in building this game. First of all, we imported the ability to scan numbers and other things out of our strings, out of our input from our keyboard. We created this application in a class called high, low, capital H, capital L. And notice we will start our class names with an uppercase letter. We start our variable names with a lowercase letter. That's a programming convention or a common way of doing things in Java. Here we had a main method, this public static void main Eclipse put in for us. You can type this from scratch by hand as well, but this just sets up a main function or a main method. This is a part of our program that runs so that we can do something like run a game. Inside, we created a few comments for ourselves to tell us what each line did. We got ready for the player to use the keyboard by setting up a scanner to scan from the system.in or the system input, which is our command line or console or terminal keyboard. And we created that scanner object and called it scan with a lowercase s. We created a string to let the user tell us whether they wanted to play again or not. We set up a game loop using a do while, and that do while was what would let the user play again if they wanted to play again. Inside our game loop, each round of the game allowed us to create a new number or let the computer pick a new number between 1 and 100. We did that with the math.random function from our math library. That's one of Java's standard libraries that we can pull in really easily into our programs. So math.random has lots of other math functions like math.sine and cosine, lots of handy useful things from math. And then we multiplied that random number between 0 and 1 by 100 to stretch it out for the range from 0 to just under 100. And we made that from 1 to just over 100 with by adding 1 to it. Then after we added 1, we dropped all that decimal off the end. So we turned it into, or forced it to cast it into an integer. And now we have a number between 1 and 100. Then we asked the user for a guess. We set up a guess variable first and set it equal to 0 because the user's not guessed yet. And we set up a while loop to take the user's guesses until they guess the correct number. So we gave the user a prompt that said something like, guess a number between 1 and 100. That gives the user the range that they need to enter. We set up our variable guess to accept the next integer that the user typed into the keyboard. So we scanned the next integer or the next whole number the user entered, and they finished that entry with the enter key. Then we had a set of 3 conditional statements. If the guess was less than the number that the computer picked above, then we said the guess was too low. Otherwise, else, if the guess was bigger than the number the computer picked, we said that's too high. Otherwise, we said, whoa, you got the right number. Correct. You win. That ended our while statement, and notice we gave some nice tab spacing inside here. This indentation tells us that we're grouping all of this code together between these curly braces. This is a compound statement or a block of statements that lets us loop while the guess is not equal to the number. When the guess did equal the number, in other words, when the user guessed correctly, we ended that while loop and we came down a little further. We asked the user, would you like to play again, and enter a yes or a no, Y or N. So we scanned the next integer, or the next token, the next word, or the next thing that the user typed in, the next group of characters. And in this case, we checked to see if play again equaled, ignoring case, a Y. So they could type a capital Y or a lowercase y. And if they did say yes, it will bring us all the way back up to the top of our do loop, our game loop, and we'll create a new number and start the guessing again. If they said anything other than yes, like if they entered a no, then it would say, thank you for playing. Goodbye. This application has all of the components of a really cool guessing game. And in fact, if you don't mind playing at the command line, this is a really fun game to play every now and then. It gave us a chance to practice something we called a binary search. A binary search just tells us to guess right in the middle of the range each time. So I guessed 50, and then that eliminated half of the numbers. If I was too high, I knew that it couldn't be bigger than 50. If I was too low, I knew that it couldn't be smaller than 50. So I eliminated half of the possibilities every time, and I was able to guess in just about 7 tries each time. 7 tries or less if we were lucky. But this has all of the components of a fun application that you might program for a game. We had loops, we have some functions that we've brought in, we have variables, we have conditions, we even have a loop for guessing until we get the right number inside a loop for playing until we decide not to play again. So lots of really rich, complex programming in just about 45 lines of code. So that's very cool stuff. When we come back in this next lesson, we're going to talk about some common things that can go wrong in this application, just in case you ran into some errors. And then we're going to jump into the next section and see how we can program this for a desktop using a graphical user interface.